Welcome to Brain Vision.
Hello, in the question we have given that consider a particle whose wave function is given by, so this wave function is psi of x is equal to a e raised to minus a x square. So in the first part, what we have to do is what we have to find out the value of this a by using the normalization condition. So let us see what is the normalization condition. So now according to the normalization condition, we have integration of minus infinity to plus infinity psi star psi dx is equals to 1. So this psi star means conjugate of this psi. So now here there is no imaginary part. So what we will get is integration of minus infinity to plus infinity. So this conjugate of psi will be a e raised to minus a x square, and this psi itself is a e raised to minus a x square dx, and that should be equal to 1 according to the normalization condition. So now we can take this a is a constant, so we can take it out of the integration. So it will be minus infinity to plus infinity e raised to minus 2ax square is equal to 1. So we have just multiplied this to exponentials. So now this is an Gaussian integral. So now this Gaussian integral, the value of this integral is, so if I have the integral of this form minus infinity to plus infinity e raised to minus ax square, so this integral is under root of pi by a. So by taking this into account, we can find this 2a is nothing but this quantity a over here. So we can calculate this a square as under root of pi by a, which is 2a over here, that is equal to 1. So from here a will be equal to this 2a by pi raised to 1 by 4. Now plugging this normalization constant in our equation, this wave function, so this wave function will turn out to be 2a by pi raised to 1 by 4 e raised to minus ax square. So this is what we get. So this is the a which we calculated, and this is the wave function after this normalization. Now in the second part, we have to find out the expectation value of x. So expectation of x is given by integration of minus infinity to plus infinity, this conjugate of psi into x into psi of x dx. So now let us plug the value of psi. So we will use the normalized wave function over here. So this will be minus infinity to plus infinity. So this will be 2a by pi raised to 1 by 4 into e raised to minus ax square times, so x into this 2a by pi raised to 1 by 4 e raised to minus ax square dx. So now we can take this constants out. So it will be 2a by pi raised to 1 by 2 integration of minus infinity to plus infinity x e raised to minus 2 ax square into dx. Now we need to calculate this integral. So we will find that this integral vanishes. So minus infinity to plus infinity x e raised to minus 2 ax square dx, this integral we have to calculate. So we will split this integral from minus infinity to 0 x e raised to minus 2 ax square dx plus integration from 0 to infinity x e raised to minus 2 ax square dx. So now we will make one variable. So let us consider u as equal to minus 2ax square. So by doing this then du will be equal to minus of 4a x dx. So now this x dx over here we have, so x dx from here will be equal to du by 4a. Now we will substitute this value. Now let us see the integral as well. So if I have, when x tends to minus infinity, so this u also tends to minus infinity. When x is equal to infinity, u tends to minus infinity. So this integral then will become, so I am directly calculating over here, so it will be equal to from minus infinity to 0 minus of du upon 4a into e raised to u plus integration of 0 to minus infinity of minus du upon 4a into e raised to u. So now from here we will get minus 1 upon 4a. Now integration of this will be e raised to u from minus infinity to 0 plus, so I will take this minus sign outside and then integrate. So this minus sign over here and then 1 upon 4a e raised to u from 0 to minus infinity. Now plugging the values, so we will get minus 1 upon 4a times, so it will be 1 upon 4a, and e raised to 0 is 1 and e raised to minus infinity is 0, so this will be only this. Then e raised to minus infinity is 0 and minus will become plus 1 upon 4a, this is equal to 0. So if this integral is 0, so the expectation value of x will be equal to 0. So I hope you find this solution useful. Thank you.